Problem 21. Evaluate the limit as x goes to infinity of 1 minus 3 over x plus 7 over x squared to the x. Trying this by direct substitution, we see that this limit looks like 1 to the infinity, and this is an indeterminate form. Since it's one of the exponential indeterminate forms, we want to evaluate the limit with natural logarithms. So first, let's rewrite this as y equals our limit, and then take the natural log of both sides of this equation. This gives us the natural log of y is equal to the natural log of our limit. 1 minus 3 over x plus 7 over x squared to the x. Since the natural log function is continuous, we can bring it inside the limit. Rewriting this as the limit as x goes to infinity, natural log of 1 minus 3 over x plus 7 over x squared to the x. Then we can use our power property for logs to take this x and bring it down in front of the natural logarithm. Evaluating by direct substitution again, we see that this looks like infinity times 0, and this is another indeterminate form. So we'll evaluate the limit by moving the simpler piece, in this case the x, into the denominator and trying again. So this looks like the limit as x goes to infinity, natural log of 1 minus 3 over x plus 7 over x squared, divided by, now this x was x to the first. We move it to the denominator and it becomes x to the negative 1. Evaluating this by direct substitution, this looks like 0 over 0. So now we can use L'Hopital's rule. So this gives us the limit as x goes to infinity. Now we take the derivative of the numerator. This gives us 1 over 1 minus 3 over x plus 7 over x squared times the derivative of the inside, 3 over x squared minus 14 over x cubed. And this is all divided by the derivative of the denominator, which is negative x to the minus 2. I want to get rid of this double-decker fraction by multiplying both numerator and denominator just by the reciprocal of this simple denominator we have here. So multiply these both by negative x squared in both numerator and denominator. That way we've got the limit as x goes to infinity. In our denominator here, this negative x to the negative 2 times negative x to the positive 2, they cancel out. So these two pieces are gone. If we distribute this negative x squared into the parentheses here, what we're left over with is 1 over 1 minus 3 over x plus 7 over x squared. That part didn't change. And here we have 3 minus 14 over x. Getting rid of our fractions again, doing a little bit of algebra. This leaves us with the limit as x goes to infinity, negative 3x squared plus 14x over x squared minus 3x plus 7. Evaluating this by direct substitution, we've got negative infinity over infinity, so we can use L'Hopital's rule. And we do that, we rewrite the limit as x goes to infinity of the derivative of the numerator, negative 6x plus 14, divided by the derivative of the denominator, 2x minus 3. Evaluating this by direct substitution, this looks like negative infinity over infinity again. So we apply L'Hopital's rule another time. This leaves us the limit as x goes to infinity of negative 6 over 2. And this leaves us with negative 3. Now we're not done, because remember, all of this was equal to the natural log of y. That is the natural log of the original limit. So right now we have natural log of y equals negative 3. So y, if we exponentiate both sides, gives us e to the negative 3. And that says that the original limit evaluates to e to the negative 3.